Hello, everyone. We are here doing our final lab, which is determination of ideal gas law constant. For this lab, we will be using our hydrogen peroxide, which I have here already. I'm going to go ahead and face the camera downward so you guys can see. Um, Here we have our thermometer, our graduated cylinder, which you notice is inverted in our 200 milliliter beaker, and I'll explain that here in just a minute. Our 10 milliliter graduated cylinder, we will need our 15 milliliter bottle, which contains a little tip that I've attached to the plastic hose. So as you can see, I've already done some preparation prior to shooting this video, just to make things a little easier, since we actually have 8 trials that we have to run through. Let me just give you some brief background. We will be using yeast as a catalyst to our hydrogen peroxide decomposition. So the purpose here is to try to extract the O2 or oxygen out of the hydrogen peroxide, and we're going to use yeast as a catalyst to speed the reaction up. Now what I've done here is I've managed to uh, invert the 50 milliliter graduated cylinder filled with water. So this here is filled with water, and it's inverted into the 250 milliliter beaker, which is also filled with water. And this hose runs from the outside, which we're going to use to connect to the bottle once the reaction has been set in motion, and going to create air bubbles that's going to run through the hose and up through the tube. So the other end of this hose is right at the edge there, right at the top. So basically, the O2 from the reaction is going to end up in the graduated cylinder, and we're going to measure based on how much water is pushed outward. Um, this is why we're using this 50 milliliter graduated cylinder. Now, for our basic air temperature, we just use our thermometer that's been sitting in my house for the past week. So the room temperature hasn't changed. It's set at 22 degrees Celsius, which is ideal room temperature. So we've recorded the air temperature for this lab in our data table 1. I've also we're also going to use our scale, because we're going to be using 0.1 gram of the yeast, which I've already put 0.1 gram here to go ahead and start our first trial. So basically, we're going to, I'm just going to clear out any hydrogen peroxide I already had in there. So using our pipette, we're going to measure 1 milliliter of water. And you know what? I don't want to bleach any of my clothes, which is the reason why I'm using my apron. I don't want to get any hydrogen peroxide in my eyes, which is why I'm wearing the goggles. I'm sorry. And we're also going to need protective gloves for our hands. So let's go ahead and measure out 1 milliliter. All right, I've poured any extra back in to the bottle. I'm gonna go ahead and, there you go, make sure it's sealed tight. Now, as you notice, I have a pan here to catch any leakage from the water. I don't want to get any of my documents or this table wet. So let's go ahead and get started with our first trial. Now, our first trial is going to consist of, again, 1 milliliter of hydrogen peroxide, 0.1 grams of the yeast, which is going to be used throughout our trials. So 1 through 8 will have 0.1 grams. So let's go ahead and run trial 1. Now, since we are using the yeast to speed the reaction up, this reaction should be completed in about a minute, so it doesn't take long. And already I'm starting to see some gas pushing the water downward. Looks like we've accumulated almost 2 milliliters of O2 in the graduated cylinder, and the reaction is still going. So we're gonna let that sit there for a couple of seconds, and then we'll be back. All right, now we're back, and we're going to take a look at how much O2. Looks like we've accumulated 2 milliliters, a little bit over 2 milliliters. So we're just going to say it's 2 milliliters, and we're going to go ahead and record that into our trial one under the data table. Now, I'm going to go ahead and pause the video and come back, and we're going to do trial two, which is going to be exactly the same. Commencing trial two. All right, now that a minute is almost up, looks like we have, again, 2 milliliters of O2 produced. We will continue on to trial number 3. Commencing trial 3, this is with 2 milliliters of hydrogen peroxide. All right, perfect, guys. It looks like we have developed 15 milliliters of O2 in this trial. We will move on to trial number 4. Commencing trial number 4. And we're off. All right, guys, it looks like it's reached a steady 15 milliliters of O2. We're going to give it a couple more seconds to see if it stays steady at 15 milliliters. All right, guys. Looks like it stayed at a steady 15 milliliters. So we're going to go ahead and record, and then we will commence trial number 5. Commencing trial number 5. Again, quick reminder: this is with 3 milliliters of hydrogen peroxide. It looks like we're getting a rapid production of O2. Looks like we just passed the 10 milliliter mark. 15 milliliter mark. 20 milliliter mark. We're getting some spillage of water as it's being pushed out of the graduated cylinder. 24 milliliter. 25 milliliters. It appears it's still pushing 25 milliliters. Now we're at 26 milliliters. We'll give it a couple of seconds, but it looks like we stopped at 26 milliliters. Yep, we have stopped at 26 milliliters. We'll be back to commence trial number 6. All right, we are commencing trial number 6. Again, we need 3 milliliters of hydrogen peroxide. Here we go. Looks like we just passed 10 milliliters. 15. 20. 24. 'Looks like we're slightly over 24. 25. All right, it looks like it's not going to rise anymore, so we're going to go ahead and record our data. It looks like 25 milliliters for trial number 6. And we'll be back for trial number 7, in which we will be using 4 milliliters of hydrogen peroxide. Commencing trial 7. Five milliliters, 10 milliliters, 15 milliliters, 20 milliliters, 25 milliliters, 30 milliliters, 35 milliliters, 36, 37, 38, 39, looks like we've stopped at 39. All right, we'll be back for trial number 8, which will be our last trial. And again, we will be using 4 milliliters of hydrogen peroxide. All right, we're here, about to commence our final trial, which is trial number 8. All right, 10 milliliters. 20 milliliters. 30 milliliters. 35 milliliters. 36. 37. All right, looks like we have stopped at 37 degrees Celsius. Yep, just double checking if we were still at 37. All right, guys. Well, that's the last and final trial. That's trial number 8. As for activity number 2 in this lab, we're going to go back to the drawing board, and we want to use data table number 2 to calculate the molarity of the hydrogen peroxide, and we're going to record it in the data table 2. We're also going to calculate the moles of hydrogen peroxide present in each trial, followed by the change in volume from activity 1 to liters. We're also going to convert the air temperature from activity 1 from Celsius to Kelvin, and we're going to plot and create a best fit line using Excel. And we're going to calculate the gas constant from the equation on our graph. So we're going to assume that the pressure is 1 atm, and then we're going to calculate for percentage error. So that would conclude this lab in determination of the gas law constant. Thank you for joining us, and I hope you enjoyed all of the labs videos that I've posted, and hopefully it would help and shed some light or some guidance on any future students taking this course. Again, that was Chemistry 1411. the Wintermaster Crash Course online course. So best of luck to you guys. Oh, one last thing before I leave you guys, I do want to give a shout out to my two lab assistants. One of which was my 7-year-old daughter, Emily. Thank you, and also my better half, Crystal. Thank you guys.